students, myself Rashmi Vaishnav, Assistant Professor in IMS UC Ghaziabad University Courses Campus. Okay, so today I am again with a new topic, and that is interpolation. Topic name is same, but there are basically different methods for different class intervals. So today I am going to be discuss Newton's backward method. It's again a very important method and use some different conditions. Let me show you my slides. Yes, basically the name of the topic is interpolation, but the subtopic is just a minute, I will show you. Yes, the name of the topic is interpolation, but the subtopic is Newton's backward method. Now, Newton's backward method, the name of the Newton's, that means obviously a mathematician, backward interpolation method. There is a term backward used. That's why, because this method is used when we have the values of calculating values at the end of the given the values of x. And all of you know the values of x we are known as argument. That means when the given argument is lies at the end of the values of x, so at that time we will find the value of, we will use the method, and that is your Newton's backward interpolation method. Okay, I'm going to be highlight here so that you can be easily understand this. Okay, so now Newton's backward interpolation method, this type of tabular is given to you in the form of x and in the form of y. Sometimes y's and sometimes fx is also indicating them. Both are same values, just the different way of representation. So okay, so if the values start with x naught, the corresponding value of y is y naught. If the values start with x1, the corresponding value is y1, and so on. x2, y2, x3, y3, and so on. Okay, so this is the basic formula which will be used in the numerical process, and that is Newton's backward interpolation formula. Here you are observably seeing that this operator, basically this operator is used for the backward interpolation. Okay, so what is the value? What is the formula? Y is equals to yn plus p. Here is a p, different term. P, this is known as backward interpolation method or backward interpolation operator yn. So you are comparing it with the backward interpolation method and forward interpolation method. In forward, we are considering only y naught term, y naught in the all the term of the formula. But here in the backward, we are using yn, all the values of y to be considered at the yn. And why yn? Because yn is the last value of the y column, and because this is a backward, so we are going to consider only the last value. If it is forward, so we are going to be consider the very first value of the y. Okay, I hope you understand. Now if you are observing it, there is a pattern. What is the pattern? I am going to be explained. Yn, simple yn. In the second term, there is a first backward difference, y1, yn. Again in the second, this is the second backward difference between the yn. This is the third. So as power is in increasing order, number 1, number 2, power is 1, power is 2, power is 3, power is 4, and so on, as according to our need. Okay, here again, here is only p. In the third term, where p plus 1 divided by factorial 2. So you can consider, you can easily observe how many number of term p is there, so divided by that factorial also. Here only one term of p, so divided by factorial 1. Here 2 terms of p, so divided by factorial 2. Here 3 terms of p, so divided by factorial 3, and so on. Now the question arises, what is p? What is p? So p, how do we calculate p? So we will calculate p x minus xn upon h. Now what are the different terms? X, that means the very first value of the x, that is it is also given to the question. Okay, when we see the numerical portion of this method, so you can easily understand. Till then, I'm just going to explain the formula part. Xn, we have all the values of h. What is h here? Basically, h is the difference between two successive values of the s. Okay, now next. Here again, I'm writing over there xn is the last value of x, because xn, if x naught is there, that means the first value of x. Okay, h. What is h? Difference between two consecutive values of h. As I told you earlier, in x. What is x? The unknown value which we need to find the values of. I hope you are clear, and in the coming example we will also much clearer that way. Okay, the example is using Newton's backward difference interpolation method, find value of F12. Now look students, F42. It's F42 from the following table. So F42 is lying somewhere between the 40 and 45. Okay, agree? 42 is lying somewhere between 40 to 45. That means it is easily we can find. That means this method, we have to use this method only, Newton's backward difference interpolation method. Okay, this is the key point which you need to be remember. Okay, if the unknown value is lying between the last values, okay, so it is mandatory to use the Newton's backward method. Okay, now let's talk about the solution part. Okay, the solution is again, you know very well in interpolation we have to create a tabular representation for all the method for solving. So here this is again a tabular representation where I will put the first column of x which is already given to us, like in the previous slide, this one at 20, 25, 30, 35, 40 and 45. Similarly, with respect to 20 there is some values, with respect to 20 and 25 and so on there are different values of y also. Okay, so this is 234, 332 and so on. Okay, so now it's time to calculate the backward difference. Now this is the first backward difference because the power is 1. This is the second backward difference, this is the third backward difference, fourth backward difference and fifth backward difference. Okay, how do I calculate? In my last lecture also I told you, but this time I am repeat how do I remember till how many vertical column we need to create the tabular representation. It is very easy to understand. How? Till then we will not get the single value. There is 45. After difference with all the values we will get a single value. That means this is the time to stop. Okay, now let's discuss how we find the value of backward operator. So this minus 22, how will I get? 332 minus 354. So I will get, because 354 is greater than 332, I will get the minus 22. Again 291 minus 332, it will give me minus 41. Again 260 minus of 291, again give me 31. 231 minus 262 and so on. That means you need to remember that every previous value is subtracted by its before one. Okay, so now how 19 I will find? I find 19 by minus, and minus sign will be in between by default. As a default you will put always minus sign. So minus 41 minus 22. Okay, the minus 41 minus, how will we get? Look here, I am going to solve minus 41 minus bracket start minus 22. Okay, so you can easily get this minus will be turns into plus. That means ki minus 41 plus 22, and which will give me definitely minus 19. So similarly, how do I get 10? Again minus 31, minus sign already in between, and minus 41. The minus become plus, that means 41 positive. Again we will get the positive answer. Similarly 2 also, that means ki minus 27 and minus 29, it becomes 20, minus 29, it becomes positive. That means ki 29, which gives me positive 2, and here you can see it very easily. Okay, now move on the third difference operator. How we are calculated? 10 minus 19, that means minus again plus. So 10 plus 19, it's 29. 2 minus 10, that means ki minus 8. 2 minus 2 gives me 0, and so on. Similarly 3 values, that means 2 more time we need to subtract it. Okay, so minus 8 minus 37, that means ki minus 37. 0 minus 8, it becomes positive 8. 2 values, that means last time we need to calculate, we need to subtract, and that is I'll get 45. After 8 minus 37, which gives us positive. So 8 plus 37, it gives me 45. Okay, so now it's time to apply the formula. A formula is yn plus p first, now this is the sign, again I'm repeating, this is the first backward operator, yn plus p plus 1 factorial 2, second forward or second backward operator yn plus p minus 1 p plus 2 factorial 3, third backward operator yn, so on. Now because we have the final value or final single value is fifth backward operator, so we need to put the values into the different values. Okay, now how we get p? As we seen in the formula, x minus xn upon h is the value of p. So x, that means ki calculating part. So calculating part 42, xn, that means ki last value, this is the previous one, last value of xn is 45. Okay, yes, 42, 45 divided by h. What is the h? Difference between the two successive values of x. That means ki 25 minus 20. You can find any two values like x0, x1, x2, x3, x3 and x4, any value. The difference must be same. Okay, put the values. Now this is the important part, how we put the value. Now p after get we will find minus negative of 0.6. Okay, now it's time to put the value. Now fx, the x we need to find 42, 204. Now from how we get the 42, this whole values we will find the tabular representation. It's very important part, class. Listen it carefully, very carefully. 204. How do I take 204? Why do I not take not choose 354? Why? Because this is the backward operator, and in backward interpolation method, we use only and only the last values of every column. Okay, the last value of every column. That means 204 is the value of yn, minus 27 is the value of first backward operator, 2 is the value of second backward operator, 0 is the value of third, 8 is the value of fourth operator, and last finally 45 is the value of fifth backward operator. I hope it is clear now. Put the values into the formula, just solve it, and finally we will get the answer 219. Yes, class, it's a numerical problem which we can easily understand by how we will solve this tabular representation. The important part, the how to arrange this tabular representation.